To start, click button 3 to activate the evaluation program. Select a measurement from your sample number and double-click.
Warning: when selecting a measurement, never hit cancel. If you hit cancel and run an evaluation, your data will be invalid. If you have already chosen your measurement of interest and wish to stay on this measurement, simply double-click the measurement again.
In order to perform cortical analysis, we must first identify the cortical region of the bone. If there is more than one bone in the scan, refer to the sketch you should have made illustrating the position of the bones in the toothpick and begin with the bone in position 1.
Note: the following instructions assume you scanned the entire bone length. Identify the slices at the start and end of your bone of interest. This identification will vary from user to user, therefore it is important to be consistent across measurements.
Subtract the starting slice number from the ending slice number, divide by 2, and add this number to the starting slice number. You have now successfully identified the midpoint of your bone of interest.
For cortical analysis, we recommend conducting the evaluation over a 1 mm length of the diaphysis at a 7.4 micron resolution. This is equivalent to about 135 slices, where the cortical region corresponds to about 67 slices greater than and 67 slices less than the identified midpoint. We denote the starting slice of this region as 67 slices less than the midpoint.
Next, go to the Zoom menu and select a magnification of your choice to zoom in on your bone of interest. The suggested magnification is 4 times.
Select the starting slice of the cortical region and click on the C.
Choose Forwards in the selection column.
To draw a contour around the surface of the bone, first hit the lasso button on the top left, hold down the mouse, and trace near the outer surface in a counterclockwise motion. Release mouse once tracing is complete. Found in the contouring window are the recommended contour thresholds. For cortical analysis, these thresholds are around 30 and 500 for the outer and inner thresholds respectively.
Contour thresholds aid the computer in integrating our area of interest across the many slices of the bone measurement and save the user from going through each slice and drawing the contour every time.
Note: contour thresholds are different from evaluation script thresholds and do not need to be the same between bones.
Double-click anywhere in the box so that the evaluation software may automatically adjust the trace you drew to the contour of the bone.
If there are any loops or other discrepancies present where the generated contour deviates from the bone's surface, you may double-click again or manually fix the error again tracing counterclockwise.
Once you are satisfied with your contour, click Iterate Forwards.
Iterate for 135 slices, then hit Stop in the contouring window to terminate iteration. If you mistakenly iterate past 135 slices, simply select the contours you'd like to erase and click Delete. Hit Yes to delete the selected contours when prompted. After all automatic contours have been drawn, scroll through the slices to check for contour accuracy, going in to fix any errors as needed.
Now that iteration is done, click T on the bottom left.
A window titled 3D Evaluation will pop up, where you must choose an evaluation script that specifies which pixels are going to be evaluated as bone in the image analysis. Evaluation scripts should be set per experiment under the advisement of the lab manager. Note that, unlike the contour thresholds, the same evaluation thresholds must be used for all measurements in the analysis. We will have a separate instructional video explaining the process of choosing appropriate evaluation thresholds that will favorably align with all samples in an experiment, not just in a single measurement.
Once the evaluation script has been chosen, hit Default VOI, then hit Start Evaluation. Defaulting the volume of interest is extremely important, as forgetting this step will stall your analysis because the software will try to analyze a square of black space, searching aimlessly for bone that it will never find. Further, when evaluating other samples in the same measurement, this step is important to adjust the analysis region to your current bone of interest from the previously contoured and analyzed bone.
Hit Yes to save all contours when prompted. Note the specimen number and the time at which you complete this step in your lab notebook, as the timestamp will allow you to keep track of the order of the output file. You can check the status of the analysis by typing QUE in the deck term window, which should already be open in the background.
In this window, you would also find a completion message once the analysis of that specific bone in the measurement has finished.
Note: If the DECterm window is not already open, navigate to the toolbar at the top of the screen, find Applications, and finally select DECterm from the drop-down menu.
Important. Do not begin the contour tracing and analysis of another bone in the same measurement while an analysis is already taking place. Wait until the previous analysis has finished, then move on to the next bone. Once completed, clear previous contours by hitting the X button. Click Yes to confirm.
Note: when performing this step, you are not erasing the contour data from the previous bone analysis, but rather you are clearing the canvas to make way for the next set of contour iterations. We will have a separate instructional video explaining the process of retrieving previous contour data after clearing. Repeat this procedure if multiple measurements need to be analyzed within the same experiment. Note: you may complete these analyses in different user sessions.